Hello students, today we will see the phenomena of electromagnetic induction. Michael Faraday in 1831, he observed that whenever magnetic field associated with the conductor was changing, it was producing a current inside the conductor, and he called this phenomena as electromagnetic induction. I'll repeat. Michael Faraday in 1831, he found that whenever a moving magnet was brought near a conductor, or if a magnet was held stationary and the conductor was moved towards or away from the magnet, it was found that there was a production of current in the coil or in the conductor, and this production of current in the conductor or the coil was called as induced current, and this phenomena was called as electromagnetic induction. So today we will see the activity which will help us to understand the phenomena of electromagnetic induction. Here we have a coil which is connected to a galvanometer, and you can see here, if a magnet is moved away from this coil, it is found that it produces an electric current in the coil, and you can see the direction of current. So if this is the direction of the current which is produced in the coil, and you can see the deflection in the galvanometer. So students, try to understand, this deflection was seen only or as long as the magnet was moving away from the coil. I repeat, when the magnet was moving away from the coil, there was deflection seen in the galvanometer, and this is the direction of current which is produced when the magnet moves away, or the north pole moves away from this, and because of this you can see the clockwise current, the current flows in the clockwise direction, and using a corkscrew rule, south pole is formed here. Okay, and due to this, induced current is produced in the conductor. You can see here, there is no battery or a cell is connected to the coil, but still there is a production of current in the conductor, and this production of current in the conductor is result of a phenomena of electromagnetic induction. Now here in the second case, we can see the magnet is held stationary and the coil is moved towards the magnet. So when the coil was moved towards the magnet and the magnet was held stationary, there was deflection seen in the galvanometer, and you can see the direction of current, and there is a change in the direction of current because the direction of motion is exactly opposite of this. Here we can see the magnet is moving away, here we can see the coil is coming towards the magnet. So the direction of current in this coil is exactly opposite of this coil, and once again, as long as that coil was moving, there was a deflection in the galvanometer, and once again this is because the magnetic field associated with the coil was changing. As long as the coil was moving towards the magnet or the magnet was moving away from the coil, there was change in the magnetic field experienced by the coils, and as long as these coils experience change in the magnetic field, there is a production of current or the production of induced current. Here we can see the coil is moved away. When the coil is moved away and the magnet is held stationary, then also we see the deflection in the current, and here the direction of motion is opposite, so the direction of current also changes. Here we can see the coil is moving towards, so the direction of current is flowing that side. Here we can see the coil is moving away from the magnet, so you can see the current is flowing this side. So these two situations are exact, direction of current is exactly opposite in this situation and in this situation, because direction of motion is exactly opposite. Now in the fourth situation, when the magnet and coil, if they are held stationary, or even if however close they are, even if the magnet is very close to it, but if coil is not moving or the magnet is not moving, then it does not produce any kind of current, or the galvanometer shows zero deflection. So these all activities tells us that as long as the coil is moving, if the magnet is held stationary, or if the coil is held stationary and the magnet is moving, the coil is experiencing change in the magnetic field, and as long as the coil or conductor experiences change in the magnetic field, there is a production of current which is called as induced current. So this phenomenon of electromagnetic induction is used in producing electric current in AC generators and DC generators.